Hello friends, welcome to new session, that is session 10 on projection of plane surfaces. Here we'll be starting problems related to front view. Okay, in all these problems we'll start from the front view for some specific reasons. Okay, here a pentagonal lamina of size 25 has edge on VP. Please understand, if they say pentagonal lamina of size 25 has an edge on VP means you start the pentagon from the front view. If the same way pentagonal lamina of size 25 has an edge on HB means you start from the top view. That means if they say any lamina, if they say edge on HP or corner on HP means you start from the top view. Edge or corner is in VP means you start from the VP, that is front view. In the same way, if they say surface is inclined at some degrees to HP means start from the top view. If the surface is inclined at some degrees to VP means start from the front view. And also you should know, you should never forget, that is for triangular lamina and pentagonal lamina, edge corner positions are the same. But whereas square lamina and hexagonal lamina, edge corner positions are different. Okay, in that way, please read the problem carefully. Here a pentagonal lamina of size 25 has an edge on VP. When they say edge on VP, immediately you should rotate from the, you should start from the front view. That is why we call it as front view starting problems. And rotate it about this till the surface of the lamina is inclined at 60 degrees to VP and edge in VP is inclined at 45 degrees to HP and all that. You just see it's all simple once you start. Okay, now you see here. So far we are starting from the top view. Now XY line, VP, HP, start from the front view. That is why front view starting problems. First, true surface of the lamina, that is pentagon in the front view. A dash, B dash, C dash, D dash, C dash you draw. That is 25, this is 25 plus 18, 25 minus 18, this is 25 plus 54, this is 25 minus 54. In that way you are able to complete this. This front view you complete. Okay, once you complete this front view, A dash, B dash, C dash, D dash, E dash, you are looking from the top, no? From here you are looking. In that way, A can be seen, B cannot be seen. A bracket B, E can be seen, C cannot be seen, E bracket C. This is D. In that way, front view and top view has been completed. And as you know here, it is D dash X dash is the median which is parallel to XY line. That is parallel to HP. In that way, whatever you get here, it is in true length. Okay. Now you see here, this is edge corner position of pentagonal lamina. If I pull this way, so that D is on XY line, you immediately say corner D is in VP. If I pull this way, so that AB is on XY line, immediately you say AB is in VP. Okay. Now you see in this problem, edge is in VP. That is why what I'll do is, edge AB is in VP. That means take the same top view. Okay. Since it is moved parallel to HP, the top view remains same. When you move it parallel to HP, this is true length, no? This is true length. And when I move it parallel to HP, so that it has some inclination of 60 degrees to VP, okay, this top view and this top view remain same. First stage top view will be same as second stage top view. Move and copy, paste and rotate in such a way that it is 60 degrees to VP. Okay, 60 degrees to VP. This top view and this top view remain same. When you're looking from here, okay, you take the projectors to that and you see here A dash, B dash, C dash, D dash, E dash. Okay. Now at this stage, what you say is edge is in VP. Which edge? AB is in VP. Correct? No? Edge is in VP. Surface or median. Median is DX. Huh? Okay. Median is this or surface. Surface is inclined at 60 degrees to VP. Okay. For this, you got the front view. And as you see here, in this, 5 edges are there except A dash, B dash, which is here. Same true length, because which is lying in VP. When it is lying in VP, in the front view you should see the true length. A dash, B dash, this is in true length. This B dash, C dash, C dash, D dash, D dash, E dash and D dash, I dash all have lost their true length. Okay. Now, the problem at this stage is edge in VP, surface inclined at 60 degrees to VP. Okay. Now, you see here what I've done. A dash B dash, hope you know, it is in true length. Correct? No? A dash B dash, it is in true length. Okay. Keeping inclinations to VP constant. If I rotate this lamina, okay, if I rotate this lamina, keeping inclinations to VP constant, okay, it is pivoted at AB, okay. If I rotate this, front view will not change, okay, because inclination to VP remains same. Like the top view starting problem, inclination to HP remains same. If you do, second stage top view will be same as third stage top view. Here, since inclination to VP remains same, second stage front view will be same as third stage front view. Because inclination to VP is 60 degree, I will not change it. I have rotated. In the process of rotation, only thing what I made is edge in VP, that is A dash B dash. Edge in VP is inclined at 45 degrees to HP. But surface inclination to VP is 60 degree only. That I have not changed. That is why this front view and this front view will remain same. Okay. Now you take the projectors down, and on this A, B, E, D, C and all that, that is on this A, B, E, C and D, get the things A, B, E, C and D, make clear dots, otherwise you get confused. Make a clear dot of 2 mm thickness in that is in solid edge. Okay, using point command and join this. Okay, this is same as 29 for VTO primer. This is the 29th problem. Okay, this is. Now you should understand, by looking at the problem itself, you should immediately understand we have started from the front view. You have started from front view means something is in VP. Now you see the first you draw the front view, that is front view top view. Okay, started from front view starting from. Then if you look at this, look at XY line always. AB is on XY line. That means edge is in VP. This is 60 degree. That is, the surface is inclined at 60 degrees to VP. Okay, 60 degrees to VP. In that way, you get the front view. Then A dash B dash, as you know, it is in true length. Edge in VP is inclined at 45 degrees to HP. In that way, the problem has been completed. Okay, now hexagonal lamina of size 25. See here, hexagonal lamina. Hexagonal lamina of size 25 has an edge on VP. If you take edge on HP, had it been edge on HP, I would have started from the top view edge position. Now it is hexagonal lamina of size 25 has an edge on VP means edge position, you start from the front view and rotate it about this stage till the surface of the lamina is inclined at 45 degrees to VP and edge in VP inclined at 45 degrees to HP. Those things will become simple, but your starting has to be proper. Be careful. Your starting has to be clearly correct. Okay. Now you see. Now edge in VP, no, you take edge position. Don't take corner position, because if it is corner in VP, I would have taken corner position. Now edge in VP. That is why you draw 25 mm hexagon in corner in edge position. A dash, B dash, C dash, D dash, E dash, F dash, A dash. 25. This is 25 minus 30. This is 25 plus 30. This is 25 minus 30. This is 25 plus 30 degree. And then you join these two. In that way, you are getting front view of the hexagon. True hexagon you draw. You start from the front view because it's all front view problems where something is in VP. So, okay. Now you got the top view. Okay. Now, if I pull this down or pull this down, it is edge only in VP. Okay. Because you have taken edge position. Okay. Now, what is the problem? Since we have moved parallel to HP, okay, since we have moved parallel to that, in that way, top view remains same. Okay, top view, this top view and this top view remains same. Okay, this is edge in VP, surface is inclined at 45 degrees to VP. This top view and this top view remains same. This is the top view, this is the top view, because this, for an imaginary line here, you have moved it parallel to HP. Okay, moved it parallel to HP. As a result, this top view and this top view will remain same. Okay. Now, once you do this, take it to the front view. Then you join all this on this A dash, B dash, C dash, D dash, E dash, F dash. You got this. Now you observe here, in this position, since it is inclined to VP at 45 degrees, here all edges are in true length. Since it is inclined at some angle to VP 45 degrees, some of the edges will lose true length. See here AF, A dash, F dash, F dash, C dash have lost true length. C dash, D dash and C dash, B dash have lost true length. But A dash, B dash and E dash, J dash, they are still in true length because they are parallel to VP. Okay. That is true length in VP you can see. Okay. A dash, B dash and C dash. Okay. C dash, A dash, B dash and E dash, J dash are still in true length. Now you see the thing. What I have said is, edge in VP is what? AB. Correct, no? Edge in VP is AB. Okay, that is A dash B dash. Edge in VP. Edge in VP is inclined at some degrees to HP. I have made keeping inclination of 45 degrees to VP constant. I have rotated this. Okay, pivoted at AB. Okay, that is AB is anyways in VP. Okay, I have rotated in such a way that edge in VP is inclined at 45 degrees to HP. Okay, since this 45 degrees to VP is constant, since I moved it with a constant inclination of 45 degrees to VP, since I rotated with a constant inclination of 45 degrees to VP about AB, okay, whatever I do, the front view remains same. Okay, in this position, what you can say, the surface is inclined at 45 degrees to VP only, but edge in VP is inclined at 45 degrees to HP. Okay, this is the thing. Looking at this, did you follow? This surface is inclined at 45 degrees to VP only, you got this front view. That means you should say this, the surface is inclined at 45 degrees to VP, but only change from here to here is edge in VP is inclined at 45 degrees to HP. That means you have brought it to one complex position like this. Now, when you are looking from the top, how it appears in the top view has to be written. Okay, take the projectors down. Take the projectors down and obtain all the points A, B, C and F on this, A and D, and join all this. In that way, you are able to get one top view for this particular problem. Okay, this is problem 43 in VTU textbook. Okay, and you should know to this level. Okay, as I said, be careful. Edge in VP means you start from the front view edge position. Edge in HP means you start from the top view edge position. Okay. In the same way, corner in HP means you start from the top view corner position. Corner in VP means start from the front view corner position of a hexagonal lamina, say. Okay. But be careful here afterwards. I have told you some of the tips. These are all front view starting problems. See here. If I say any lamina has an edge in HP means immediately start from the top view. Edge in VP means immediately start from the front view. Okay. Corner in HP means start from the top view. Corner in VP means start from the front view. Okay. Surface is inclined at some degrees to HP means start from the top view. Surface is inclined at some degrees to VP means start from the front view. These are all the clues what I have told you, which will be used to you, which we have for doing problems later on, any complex problems given. Okay, now looking at this itself, you are able to say, you have started from front view, immediately you will know it's the front view starting problem, something will be in VP. Now if you see here, AB is in VP, edge AB is in VP, okay, edge is in VP, surface inclined at 45 degrees to VP. This you have got. Now here what I have done, the surface inclined at 45 degrees to VP, but edge in VP is inclined at 45 degrees to HP. I have rotated in such a way, keeping inclination constant, I have rotated this in such a way that the edge in VP is inclined at 45 degrees to HP. Okay, in this complex position, when you look from the top, how it appears in the top view has been done. This is the top view and front view for this complex position. Okay, this completes session 10. Session 10 on projection of plane surfaces under front view starting category. Thank you very much. Thank you very much. Thanks again. Thank you very much for watching.